Okay, so welcome to the 2015 mock exam on DCG, and it's doing conics, right? So we have a 3D graphic of a jug. So there's a cone here that's truncated, so the top cut off, and then the top portion is a cone upside down that's truncated there and there. So it's cut. It's cut at an angle, cut horizontally. So B2 shows a plan and elevation of a conical surface which is truncated in a similar fashion to the top portion. Part A. Draw the given elevation and plan and project an end view in the direction of arrow A. So if the end view or the end elevation is done this way, the end elevation will be drawn on the right of the elevation. Now what's important to note is the black circle here on the inside represents here, this line here in elevation. It's an edge of the circular surface. If you cut a cone, a right base cone, cut inverted or uprighted, any horizontal section will produce a circle. So that's a circle there. Now this is truncated, so in plan that's going to appear as an ellipse. So we'll have to draw that, and we'll draw it using elements. So I'm going to get started. A reminder, it's scale 1:2. So 60, 70, 90, 75. Okay, so I'll get my XY line here now. One moment. Okay, so 90 up, this is max height. Then we have 60 up as well. Okay, and then 70 up from the XY line, and center here, there. Okay, so I can go across. It says in plan that the diameter is 150, so that's 75 after the scale. So how am I going to get that stepped equally? So I'm going to just on a light line mark 75. I'm going to take my compass, I'm going to set my compass to the length of the line and bisect it. So it's just light construction work. So there's half of this 75 there. So I can take that and step it either side. Now I can get to business. So I'm just going to draw a light line here, to take my set square now, join these points together. Same then over here. Connect then these here. Connect those. Now, the plan view. So there I can start my plan view. So I'm drawing in the outline of the cone. Now to get the inside black circle, so I'm going to bring my compass up here, take the distance there, bring it down here, and this is that's the radius of the circle in plan. Right. Now I need to get the elliptical section here in plan. So what I'm going to have to do is divide my cone up in plan into elements. Okay, now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, so let's bring them up to elevation. So I'm marking those points in elevation, and they're going on the base of the cone, so the top essentially. And then I'm going to label them 0, 11/1, 10/2, 9/3, 8/4, 7/5. Okay, if they join to the apex in plan, they join to the apex in every view. So I'm going to join them lightly to the apex. Now, where these generators cut the cone, that's points on the elliptical cut surface. Okay, so here we have we have a point there A, then we have B and C, D and E, F and G, H and I, J and K, and L. So we need to bring those points down to plan, right? So A is on the line 0 to the apex, so there's point A. B and C are on the lines 11 to the apex and 1 to the apex, so there's B and C. D and E are on the lines 10 and 2, so that's D, that's E. Okay, F and G now are going to be hard to get, so what we're going to use is a horizontal section, right? Horizontal sections of an upright cone, horizontal sections of a right base cone, whether it's upright or inverted, produce circles. So if I draw a horizontal line there cutting through the cone, it's going to produce a circle. So if I take my compass here now, having set to that radius, there's going to be G and there's F. Now we want to get H. H is on the line 8 to the apex, and J is on the line, I is on the line 4 to the apex, so 4 to the center. Now J and K, so there's J and there's K, and then point L is there. Point L is there. Right, we can freehand sketch them in, but I'm going to do that later. I'm going to sketch it in later. So what I need to do next is I need to draw the end view. So I'm going to draw a vertical line here for the YY line. I'm going to bring each of the points across. So all the letters, bring it across until it hits the YY line. Now, where it hits the YY line, we can do our 45 degrees. Now I'm going to bring all these lines, okay, straight up in a moment's time. But first I'll just bring the points from elevation across. So the letters in elevation, just bring them straight across. Okay, so point I'm going to bring up point G. So there's G. I'm going to bring up point I. There's I. Okay, I'm going to bring up point E. There's E. You got to be careful that you label these right. Now I'll zoom in a little bit. So point K. There's K. Point C. So there's A and C rather. There's A, or sorry, not point C, A and L. There's point L. Right, then B. Okay, J. So yeah, that was J. Point D. Point H, over and up. And then point F I have yet to do. So over and up from point H. Or sorry, what's that say? Not H, F rather, sorry. F. So now I have my point B in the wrong, I have one of my letters in the wrong position. So this one here that I labeled. So I need to go down and track it back. So that was point D. So D should have been, that's D there. And then this is point F. Okay, and do I need any other points? Good, then I have I, H. Need to do H, forgot to do H. So up, across there, and then here's point H. Right, I'm going to pause the video and sketch all of these in a moment's time. Now just to do this bottom here, so I'm going to bring the circle across the YY line, up, and same here. So up from it. There we go. This will be, they'll be heavy in between them. Now I'm going to pause and sketch them in. So I have them sketched in, and I need to join G to this point here and F to this point here. Now the next part of the question says draw the true shape of the elliptical section. So I'm going to look perpendicular to the edge of the elliptical section. Now it'll be tight to space here, and I'm going to literally draw in my x1 y1 line right here, so very close to it. Now I'm going to project perpendicular to the x1 y1 line from each of the points. Yeah, and this is essentially an auxiliary plan because it's projected from the elevation, and I'm going to take my distances from the x1 y1 line down to plan. Okay, so I can get started on that. Right, now, because I'm tight for space, I'm going to draw a datum line. So I'm just going to draw a line parallel to the XY line that serves as a datum to take my distances back. So for an auxiliary plan, you go from the XY line down to plan. As I said, I'm short for space, so I'm just moving my, compass. Now, I'm going for speed, I'm going to put the datum line, or the compass onto the center line, and I'm going to find the axis. So this allows you to pick up the pace. And then for point A is going to be on that axis. So there's A. Point L is going to be on that axis as well. Then for C and B, so I can put my compass on the axis. C and B are going to be the same. So there's C and B. D and E are the same. So I can mark it in there. G and F are the same. Okay, I and H are the same. Compass on the axis. Bring it to the axis up here and mark it in. It's the same thing as putting your compass on the datum line and moving them to each point. It's just quicker, that's all. And then J and K. Right, so I shall freehand sketch them in a short while. So the true shape will be up there. I'll freehand sketch all the points in a moment. Right, the next part of the question says, draw the elevation of a focal sphere and establish the position of one of the focal points and the directrix of the elliptical cut surface S. So draw the elevation of a focal sphere. So the sphere is a tangent to the extreme generator and the cut surface. So I have to bisect that angle until it hits the center line and go perpendicular to the extreme generator to get the radius. The focal point will be where the sphere is a tangent to the cut surface. The directrix is a horizontal line passed through the point of contact between the sphere and the cone, and the cut surface brought down until they intersect. Right, so I'm going to take my compass here. I'm going to bisect this angle. So I'm bisecting the angle of the cone. So just to clarify, I'm bisecting this angle here. Now, there's the center point of the focal sphere. If I want to get the radius, I'm going to take my set square, line it up with the extreme generator, slide it along to the center point, and there's the point of contact. Right. Here's the sphere now. There. Yeah, I'm a bit off there. I'm going to pause that and fix that. So fix that sphere. Right. So to get the focal point, we're going to line our set square up with the cut surface, and we're going to draw a line 90 degrees to the cut surface from the center point. Now there's the point of contact between the cut surface and the sphere. So if you bring this point up here, that's the focal point there. So that's the focal point between the sphere and the cut surface. Right, the next thing to do now is we're going to have to find the directrix. So the directrix is the line of intersection between a horizontal plane that passes through the point of contact between this focal sphere and the extreme generator of the cone. So we can just run it along there. And then the cut surface is extended on down. Okay, and where they intersect is a point view of the directrix. And then we can bring that, what you call it, line then back out. We can project that back up towards our true shape. That's our directrix there. So this directrix. Now, I'd love a question where they asked, find the dihedral angle between the cut surface of the cone and the horizontal plane that passes through the point of contact between the sphere and the extreme generator of the cone. And the dihedral angle will be right there because both planes appear as an edge. There's a line of intersection between the planes, true length, there, point view there, so both surfaces do appear as an edge. Now, so that's it. Cheers, thank you, bye bye. Sorry, I forgot to sketch in the points there, which I'll do now. So I'm just going to pause and sketch it in. So that's what it looks like when it's done. So cheers, thank you, bye bye.